that being said, and appreciating the fact that some of you are doing that, our next speaker will speak for 15 minutes or less as dictated by this magic timer. Off you go.
Okay, thank you. Hi everyone, my name is Eyal. I work for Red Hat. And just a little bit about myself, I like Jenkins. I manage actually a CI or a DevOps team inside Red Hat and also on the overt open source projects. I highly recommend you go and check out our booth on the K building. So all of my team is doing automation, a lot of cool stuff. And I'd like to show you one of those tools that we use to leverage and to automate a lot of things that you might not have thought of using that. Okay, so how many of you have this boss that comes to you every day and tells you every morning, listen, we need to do this task, we need to automate it or not, and you say, oh well, I'll just write a bash script to do that. It's quite simple, and you spend a few hours and you're done and you're happy about that and you go drink your coffee. But a day later he says, listen, we have to do this as well, but this time it's a different system and it's a bit different. So you say, I can't use really the same script, so I write another script. I mean, it's a few lines of code. What's the problem? And then you end up writing script after script. And you've got these massive sets of bash scripts that no one knows how to maintain, multiple code duplication, not really manageable. So you actually end up with yubs, yet another bash script. And it's really bad, because if you start to think about scale and manageability, and you have other, if you want the whole team to maintain the same code, and also if you work in a large enterprise like Red Hat and you develop DevOps tools, there is a high probability that other DevOps teams will want to use that. But their use cases is different. It's different product, it's different flows. So what will end up is they will write their own bash script, and there would be this gigantic heap of script that can't be reused, full of bugs, and not really reusable. So I call it disconnected automation, because you have a lot of tools that you use as part of your DevOps. Foreman, some of you might know, great provisioning system. They also have a booth on the K building. Jenkins, of course. Jira or any other ticketing system. You might want to automate Jenkins to open new tickets, or you want to track open issues that are affecting jobs in Jenkins. Bugzilla, of course. If any of you attended my former Lightning talk, we talked about a little bit about how we interact Gerrit with Bugzilla. So you end up with a lot of APIs you need to handle. And obviously, every tool has a different API. Some of it a different language, might be in Ruby, might be in Python, might be in Bash. So you get the idea, but you don't want to manage a full set of tools, even if it's like great tools. For example, Foreman has a CLI called Hammer, which is great by its own, but it doesn't help me connect with Jenkins or with Gerrit or with Bugzilla. So this is the problem that I call disconnected automation. But actually, it doesn't have to be that way, because there should be one tool that will allow us a common interface, that everyone will use the same tool. You can write actually common functions that other teams can use and reuse the code. And this is basically Fabric. So this is what I want to talk to you about. Fabric basically it's an orchestration environment. It's not really like Puppet. Puppet is more like maintaining the status of your environment and your configuration. Fabric is Think of it like SSH on steroids. You can write any code you want, whether it's updating your entire servers, or I'll give you a live example. A few weeks ago, we had a nasty bug with NFS mounts got disconnected during automation. So during a debug session, we just needed, we found out something with RPC bind, and we have like 200 servers, and we wanted to know how many processes of RPC bind is running on each server. So it's a few lines of Fabric code. You run it, Fabric allows you to run in parallel, gives you logging, basically gives you a nice API that is already there. You just need to write the logic and the code. A little bit about Fabric. Really easy to use. You just install it with yum or pip, preferably yum. You write simple Python module, same as you would write any other Python code, and you run it from the command line. Simple as that. Just run fab minus age. You give it the list of servers that you want to run on, and the name of the task that you want to run. What's really nice here is you don't have to give it like manual list of hosts. You can connect it. You can concat it with other tasks. For example, you can write a task for foreman. If you manage your host inventory via foreman, you can say, okay, on foreman search, and you give it a custom foreman search. Give me all the hosts with this operating system or on this host group, and you will get the list of hosts, and then the task that you want to run will run on these hosts. So it's really easy, really connects to your existing infrastructure. So just a simple task. You can see just if you want to yum update all your hosts, you just create a task. Obviously write the documentation, and this is it. Run yum update minus y. If you want to reboot the host, that's like a param to the task, true or false, and that's it. You run it with one line, minus uppercase P, parallel, run it on all the servers at once, and it will give you the output on every server, and be simple as that. Now for some cool stuff. So obviously that's the most obvious use case, right? You want to update like multiple servers, and you want to maybe check some services, and maybe update the NTP, but that's really kid stuff. We took the Fabric and took it to another level. We actually use it as a main tool for not only updating, but monitoring our DevOps infrastructure. For example, any of you use Jenkins for your CI environment? Great. So you probably know the problem of monitoring unstable jobs. It's not that pleasant job. Sometimes you can't just really send the developer or the committer an email saying, listen, you broke the job. Sometimes you have infra issues, like the job failed because the storage was down, or maybe the automation code that runs has its own bug, and they have to create new RPMs, so that's another issue. All sorts of issues that can occur. And we found it very hard to track the reasons of those unstable jobs. So what we did is actually using Fabric, we created an automated Jenkins unstable report. So I don't know if you can see, but these are unstable jobs and their description. It's a screenshot from Jenkins. So we thought about what was the easiest way to track it. So we said, okay, every job, once we do the debug and the drill down, the root cause analysis, we'll write the reason for the failure. And then we saw that there were different types of reasons. So for example, it can be a Bugzilla bug. It can be a Jira, which is the tracking system for the QA. It can be a downstream or upstream Gerrit. And it can be a simple work in progress for any of the team. So how is Fabric comes in place? It actually, we invented like an API. We just write, for example, BZ colon a number, or Jira colon a number, and Fabric scans the job's description It actually goes to each system and updates. So for Bugzilla, it will go to Bugzilla and fetch the bug assignee, the status, the summary. The same for Jira, same for Gerrit. This gives us an immediate view of the system, and that's how we can communicate or follow up on those jobs without constantly debugging it again and again. So simple example, we're accessing 3 or 5 APIs via the Fabric. It's all managed in the same code, sharing code between the APIs. So that's much better than a slew of bash scripts. Another cool stuff we're doing that, it's quite a complex system we developed, but I just touch it really briefly. It's dynamic host pooling and provisioning. As part of a virtualization product, we have to use bare metal machines for our testing. Obviously, we need to create VMs and test that the process is working. And usually, you have more tests than bare metal. Bare metal is a scarce resource. So we kind of wrote an API that is based on Foreman. And it kind of gives you a pooling system to reserve a host, to release, to reprovision a host for your every need, with each operating system you need or any of your test flows. So Fabric here is the entry point. It contacts the Foreman API and actually gives you the ability to release or do any of those tasks to manage your host in your various labs. Other cool stuff that I didn't have time to show you today. We found out that we have multiple Jenkins jobs, like hundreds of jobs that are getting obsolete, especially if you use Jenkins Job Builder. So we need to delete them. We just wrote a task. You give it a prefix or a suffix of Jenkins job, and it uses the Jenkins API to delete it. It gives you a nice summary, really easy. We connected to Nagios. So we have monitoring, like for example, showing all the Jenkins offline slaves. If you need to monitor it on a daily or a weekly basis. Also showing the queue size of the Jenkins. If you want to get alerted if it's getting too big or too small. Adding host to Foreman. Adding host to Foreman requires you to install NTP, sign the certificate, and a list of manual tasks that usually is annoying. We just automated that with Fabric, one that does everything in a sequence, all on its own. Running Puppet, also very simple. If you want to, all your hosts were stuck or something, and you want to enforce running now Puppet update, you can do that. And also, as part of our CI environment, we run integration tests before we release something to the QE. It involves installing a new host, running the engine setup, running the whole flow of the setup. We just automated that with Fabric, single line, and it's done. That's it. Basically, you're more than welcome to come visit me at the Overt booth. Ask anything you want. I'm also on Overt channel in IRC and the email. If you have any question, I'm not sure if we have time.
Yeah, okay, thank you, Eyal, for your great talk.
All right.
So does anybody have questions? So just raise your hand.
So, thank you for the presentation. Let's say I want to use Fabric and I want to roll out some changes on a subset of hosts that I have. How would you do that?
Sorry, could you repeat the last sentence?
Rolling out a change on a subset of hosts. So let's say I have load balancers and I've tested it and everything is fine, but I still don't want to deploy it on all the load balancers, just a percentage of it. So I can do a gradual rollout instead of a big bang or a sequential and wait for it.
Sure. I mean, Fabric gives you the option to write -h, just list a comma-separated list of hosts that you want to run it on. You can run it on one host, see the result, and then run it on
yeah, sure. But then I need to specify it. I would like say like run this on 5 hosts of the pool that I have and show me which host you pick.
So this is why I use Foreman. Foreman gives me that abstraction. We have host groups that cluster a specific type of hosts, and I say to Fabric, on this host group, on this set of hosts, please run this task. So you don't have to use Foreman, but if you write a Fabric task that its output will give you a list of hosts depending on a certain criteria, then there you go. You just...
Yeah, but I'm lazy. I don't want to do that.
All right.
So I have a host group, and that's the group of hosts that I want to deploy something on, but just a percentage. So because I don't want to say like do a 100 host or a 500 because I have a lot of hosts. I want to say I do 1% of the host.
I'm not sure how you can do that, but let's talk after
cool. Sure. Thank you.
No worries.
Okay, any more questions?
All right. Is there any mechanism to recover from tasks which failed during the run?
Basically, you have a few flags that you can use. For example, -W, which will ignore warnings. Like if you don't want the full task to fail if one host is down, so you can use that. There are a few parameters you can use, but if something executed on a host, even partially, you can't roll it back. It's the same thing as you run an SSH command, a remote SSH.
Okay, do we have any more questions?
Is there one here downstairs? Roll back, all right. But I think there's another one.
When you have lots of machines and you want to provision something, you should wait for the output, right? So is there any way to parallelize it somehow and make the process faster?
Yeah, of course. It's all the Fabric tests, if you use them uppercase -P, they run in parallel, and you will see the output as one host is finished, you will see the output, and it will accumulate until it's ending. And you can use the -W to ignore bad hosts, so it won't stop your task. So yeah, that's its power. Otherwise, you will just run like SSH script, but this is like gives you a parallelism out of the box.
All right, thank you.
So yeah, if you have further questions, you can visit Eyal at the Overt desk also.
Thanks, guys.
Sorry? Ask the next speaker to come forward. Okay, so for the